Hi everyone, my name is Sai Venom and I'm with the IBM Cloud team. Welcome to another episode of Cloud Lab. Today I'm joined by Matt Parents. Matt, do you want to introduce yourself?
My name's Matt Parents. I'm one of the lead engineers in the IBM Garage for Cloud, and I'm focused at helping clients drive innovation with IBM Cloud and OpenShift.
Okay, so for our viewers that are hearing about the Garage for the first time, can you quickly explain what the Garage team does?
Yeah, what we're optimized to do is help customers deliver first-of-a-kind solutions using IBM Cloud. And we drive this through what we call our 6-week MVPs, where we go into a design thinking workshop, we rapidly extract the needs for the business, and then we turn it into a very agile, quick execution for cloud native delivery.
As a developer, I think that's great with container technology, the fact that you can build once and run anywhere, right? So for IT leaders, where does that decision come up when deciding to move forward with Kubernetes? How do they decide how to move forward with cloud providers being an option versus running something on-prem and kind of the different options out there?
So we're seeing absolutely the advent of multi-cloud. Every client I visit has got more than one cloud, if not two. They're struggling with the dilemma of how to modernize legacy applications on-prem, and then they also have certain business models that work better in the public cloud. So they, as an IT leader, they want to make architectural decisions around technology that will future-proof them from either a vendor lock-in or future-proof them for their ability to scale. And the component of building a microservice into a container and then orchestrating it in a common managed platform like Kubernetes, and then making the decision to either run it locally on your local environments or out in a public cloud, or put it closer to a piece of business function that may be on a specific cloud that you need to interlock with. So it's giving IT leaders a very much common playing field for delivering software.
How do we make this easier? Especially as a company like IBM, we need to really think about our customers and the fact that they do have so many choices. So how are we making it a little bit easier for them to get started?
So I'd say that this is one of the key motivations for IBM's acquisition of Red Hat and the provisioning of OpenShift. One of the real value propositions of OpenShift is that it is making Kubernetes development a lot easier and making it more straightforward. I'll use the analogy of a chef with a really sharp knife. If you think of a raw vanilla Kubernetes as a very sharp knife, you need to be highly trained to know how to use it, to make the right incision, to make the right execution. And what OpenShift is doing is making it simpler for mere mortals to approach that development platform, and it's smoothing off a lot of the rough edges or sharp edges, so you're less likely to hurt yourself when you're...
Maybe adding a handle to that sharp
putting
knife.
A handle in it,
right.
putting it in a case, having a safe place to store it. I know we can keep elaborating on that analogy, but if you don't know what you're doing and you come up to Kubernetes, you can get lost or find it hard to work with. And OpenShift's job is to make the developer experience as smooth and as easy as possible.
Right.
And they've done a really good job of embedding the tools and bringing the life cycle around how you build cloud native applications onto that platform.
I think we want to drill into one of these topics. So I think a core part of doing cloud native is DevOps and figuring out how to get through that DevOps lifecycle. So I know that, Matt, you work quite a bit, especially, I know you work with a lot of customers through the Garage process, and I know that DevOps is a big concern for a lot of these customers. So can you talk a little bit about why that's such a core part of cloud native and what you're doing to kind of help alleviate some of those concerns when you're prototyping some of these capabilities?
Right. So as we've talked previously about breaking software into smaller components and packaging them up, one of the key things you need is discipline, and a discipline in consistency. And I think the other aspect is less humans touching things. So automation, validation, testing. So one of the things DevOps really brings to this cloud native development lifecycle is it allows to put a robust, repeatable process so that when you make a code change, you know the thing that you arrive at is consistently the same every time. And that through that process of DevOps, you're validating that its code quality is high enough, it's tested, it scales, it does all the things you need. So when you take that component and you put it out ready for customers to use, you know that it's offering the flexibility that you need.
Right, exactly. So for that dev team or the ops team, instead of them having to from scratch figure out that entire DevOps pipeline and toolchain flow, they can go with something like where with OpenShift, some of those capabilities are already embedded,
Yep.
but then you have that experience around it to make it a little bit easier.
That's correct.
Yeah. So I know that we could talk about DevOps for the next hour, but instead, let's actually go to the Cloud Lab and sketch out some of these capabilities. And I want to start with laying out an example cloud native application that maybe I've architected and I know how to build it out. So let's start with the front end. Let's say we'll call this a UI portion here. Below that, we'll say we've got the BFF or the backend for front end. So this is actually serving the APIs for that UI to kind of serve up information. And so we'll say the UI accesses the BFF. And that, in turn, is going to access, we'll say, the microservice or the backend layer. So in here, let's say backend. Now, obviously, for higher value services, let's say that backend, maybe it goes out to something like some AI capabilities, and in addition, maybe a database. So Matt, as the expert, I'm going to kind of hand this off to you. This is the application architecture that I want. How do I start migrating this over to a cloud-native approach, and what are the DevOps considerations that I need to take?
Okay, so you've already laid out some of the separation of concerns. You've got a component that is focused on delivering a user experience, which again can be containerized and packaged. You've then maybe got a backend for front end, which is serving UI-friendly APIs and abstracting and orchestrating across a number of backend. So you've got your three logical points. So moving forward, what you typically do is take this component and start to break it into a pipeline that will enable you to offer some discipline around how you build, deploy, and test. So what we typically do here is we're going to use DevOps, and we're going to create a pipeline. And this pipeline is going to consist of a number of stages that will take us through the life cycle of building and package this component. So typically, the first step is to clone the code from your source code management, which is typically Git or some kind of Git-based technology, GitHub, GitLab. And then the first step is to build the app. So build app.
So in this portion, when you're actually building out the application, sure, you have considerations for a Node.js app. You have things like NPM, Java. You have to figure out the build process for that. So the pipeline is kind of configured to build each one of these components based on the programming language that I chose.
So typically you have one pipeline per component. And as you correctly stated, if you're building a UI and it's got React in it, you're going to use a Webpack to build the UI TypeScript code, package that into a form that will then be packaged ready for run.
Okay.
So there are steps, and again, with a Spring app, Spring Boot app, you'll package it using Maven or Gradle, and with Node.js, you'd use NPM and various other steps. So this part of the pipeline is about packaging the source code in the way that it's needed to then be run.
Right.
But then typically at this point, the next step is to run a set of tests. So you run a set of unit tests against the code, you validate code coverage, and then this enables you to determine whether any code changes that have been made in the pipeline are valid. And again, these steps are sequentially moving along. And if any one of these fails, it will stop the build. You'll be informed as a developer, and then you'll go back and fix the code or fix the tests.
So just to kind of clarify, at this level, we're going to do unit tests, so tests within kind of the app context, not really considering connections between the different components.
Yeah, today we're not going to cover the integration story or performance testing, but typically when you're building a pipeline, you need to test the code that you've written using various techniques. Typically, you can use test-driven development, which is a concept we use in the garage. So you write the test first and then create the code to validate that. You can use other frameworks. Most of the major programming models have good test frameworks around them, whether it's Java, Node, or other languages. So next step, again, one of the key things to try and drive for is to get to a point of continuous delivery. This is a continuous integration pipeline. But if you fail the test, then that's going to prevent this package of code moving into a test environment. So another common technique we use is code scanning or vulnerability scanning or security scanning. So what we do here is we're looking for vulnerabilities, we're looking for test coverage, we're looking for quality gates. So if your code isn't a good enough quality, both from a code analysis perspective, we could actually stop the build and say we're not going to move this microservice further along the build process.
Right. So if we were, building out this, let's say the BFF application was a container-based application running in IKS, IBM Cloud Kubernetes Service. I know we actually have some capabilities to allow you to test for that scanning, right? It's the vulnerability advisor. So would that exist in this phase then? So you tested the code, then you kind of...
Yeah, you can. I mean, again, I'm lumping in one or two different stages here. You can do vulnerability scan, you can do code scan. It's kind of a common technique to make sure. I mean, the good thing about vulnerability scanning is you're validating there's no security holes in the Docker image or the container image as you build it.
Got it. Okay, so now that we've got kind of up to the scanning phase, what's our next phase? Where are we going from there?
So the next step is to take the application that we built and tested and scanned, and now we're going to build it into an image. So we call it a build image. So what this is doing is using the tools to package up the code that we built and put it inside a container. And once we've built the image, we then store that image out in an image registry with a tagged version that goes with it.
Right. So I guess I kind of got ahead of that right there. So that's where we would actually do that vulnerability scanning, is once we've tested the code itself, done some scanning at that level. Once we build the image, then something like vulnerability advisor is where it comes.
So you could have that as another stage, but again, if the vulnerability is poor, then you could prevent this moving forward, and that will inform the developers to either upgrade the level of base images they're using or fix a number of the packages that they've included in it.
So basically every step of the way, if anything kind of fails, you're kind of notified of that, and you can go back and fix that.
Right, and at the next stage is now you have an image, the next thing is to deploy it. So what we're looking to do is to take that image and deploy it inside an OpenShift managed platform, so it will move the container from the image registry and deploy it. And there's a number of different techniques for deployment that's using. Some developers are using Helm. The more modern approach is looking to use operators, so there's a life cycle around that component when it gets deployed.
So, and then this deploy, say I have a Kubernetes environment. So we would deploy an application, let's say the BFF application, into that Kubernetes environment, right?
Yep.
Okay, and I'm guessing at this phase, this is still part of the developer flow. Would this be the dev environment that you're pushing into, or the test environment?
Yeah, so typically a continuous integration flow builds and packages the code up for development environment. When we talk in a few seconds, we'll talk a bit more about how we move that package of code from the container registry out into a test environment.
Got it. So right here, we'll put dev.
Yep.
Okay.
So the final step is to validate the health. So what you're really asking here is the container running? Is it sending back operational information that you can determine that it's healthy enough to validate that not only that the tests have run, but actually it started and it's communicating with its dependent services and it's going to operate in the way that you'd expect it to.
Of course, yeah. So this is kind of where you kind of connect it up to the different components and make sure they're all working together seamlessly. This is where you would probably find issues with integration or how the teams are kind of connecting up with each other. API contracts and those kind of things, those issues will start to bubble up in this phase.
Yes, and again, the health endpoint's important because you can hook that into operational tools like Sysdig and LogDNA and other monitoring that will give you a better feel of the current state of your applications as they run. So this has got us as far through the development cycle. The next step is to, and again, introduce, this is starting to be common in the industry, is to use a technique called Git Ops, where you would now say, I've got my application, I've built it, I've packaged it, I've tested it, I've validated it. What I'm now going to do is update a Git repo with the build number, the tagged version, and the reference point to the image registry. And then Git Ops can then trigger off a deployment of that image out into a test environment with all the other components that go with it. And there are a number of Git Ops tools out in the market, and one of the ones we use in the garage is Argo CD, which allows you to monitor a webhook of a Git repo, and then it will pull the image, it will pull the deployment reference, and then package it and deploy it ready for use and testing.
So basically the same quality that developers have been doing forever with SCMs to manage, different versions of their code. Now ops teams are kind of taking advantage of that same approach to basically operationalize the deployment of these actual images, containers, applications.
Absolutely, and it comes back to a point we made earlier, that this is about discipline and repeatability. There's no humans hurt in this process as you go through it. And the less humans touching these steps, the better. Again, one of the things we often do with clients is we'll work with them and we'll discover that there's some human process in the middle, and that really slows down your ability to execute.
Exactly.
So it's about automation, discipline, and repeatability. And if you can get to this point and prove that this code is good enough to run in production, you can then start to move towards that golden milestone of delivering continuous delivery.
Right. So once you've automated all of this, that's when you can truly say, you have CI, CD.
Yeah.
That's when you can finally get to that level. Okay, so honestly, Matt, this was a great overview of all the concepts we've discussed already. Let's head back and actually dive in a little bit and see how some of these capabilities look in IBM Cloud or potentially even OpenShift.
Yeah, great.
All right, so that was great to see how all of those concepts are laid out in the Cloud Lab, but let's take it a step further and see how some of these capabilities actually look.
Okay, so what I've got here is a managed OpenShift environment running on the IBM Cloud. I've come into the OpenShift console, and from here I can navigate to my application console where I can manage my different projects and my different namespaces. So the way I've set this up is I've got a development namespace or project, and within there I have a number of build pipelines that are managing my source code and taking me through the different stages from build, test, scan, deployment, and health check, which we discussed earlier.
Wow. And so taking a look at this, it looks like, if I had to guess, for each of the individual applications that are running in the dev environment, you've got kind of their own pipelines built out, and it even shows you how long each step takes and that kind of thing, source repository. Okay, so this is kind of a representation of all of the back-end pipeline logic that's going on. Do you want to drill in a little bit deeper and show me what this is powered by?
Yeah, so again, Red Hat is predominantly using open source components. Red Hat is a very popular continuous integration technology. Mm-hmm. They've put a very nice interface, which is what I meant earlier when we talked about making things easier and approachable. If I actually drill into a particular build, I can actually see the detail, when it completed, how long it took, and then if I jump into a log, I'm now dropping into the individual Jenkins environment, and I'm now working with the native Jenkins that's installed.
So clearly there's a tight integration between the kind of Jenkins capability as well as OpenShift that's allowing us to have OpenShift kind of show us this broader view of the pipeline. But then if we wanted to, at the end of the day, we could dive in deeper, and we see you have the Jenkins capability loaded here. So this is kind of the raw open source pipeline tool that's powering OpenShift.
And I can drop into the logging, I can go and look at, if there's a failure, I can go and look at the different environments. And again, one of the nice benefits of Jenkins is it has a rich ecosystem of plugins, and it's been extended to support Kubernetes to do deployment and management in that environment.
That's great to see. So I know that for this particular example, we're using Jenkins to deploy Kubernetes or OpenShift-based applications. What if we wanted to deploy something entirely different? Say we wanted to work with Cloud Foundry applications or a serverless function that we wanted to deploy. Is that something that we can also leverage the OpenShift DevOps pipelines to do?
The pipelines are optimized in the OpenShift environment to work with containers that run on OpenShift. Mm-hmm. You could extend them to manage serverless technology, or you could build a Cloud Foundry and then target it to a Cloud Foundry environment if you wanted to. But there are other DevOps tools in the family around the IBM Cloud that are more optimized for doing that.
All right, that was a great demo. I think it was really good for us to be able to see how some of these components actually play out in the OpenShift offering in IBM Cloud. I want to thank you, Matt, for joining us today for this Cloud Native webinar. If you want to learn more or get started yourself, check out some of the related links that we have attached, and be sure to stay tuned for more videos like this in the future. Thank you.